Hi, Bill Barber from Poliigon here. In this video we're going to be taking one of our materials into Unreal again, but this time using one of the displacement textures with Unreal's tessellation feature. First though, let's take a quick look at the file that we'll be using during this video. It's ground asphalt broken 001. I already have that saved to my hard drive and I'll include a link to it below the video. You've probably heard of a bump map before, which is used to artificially give the impression of height in a material. Well, a displacement map is different. It is used to literally deform the object based on the values of the texture, with the black areas being the deep crevices and the white areas being the peaks. Now in Unreal this is done by utilising a feature called tessellation. So let's jump over and take a look at how we do it. So this is the scene that we'll be using today. Again, it's a simple plane and a HDR lighting setup, and that's pretty much it. One difference from last time though, this plane is not one of the auto-generated planes from Unreal. It's one I brought in that I made quickly in a external application. Reason being, for tessellation to work, the mesh already needs to have quite a bit of geometry. As you'll see here, this mesh is made up of lots of little triangles, whereas the default mesh is just it's just two triangles basically, which it isn't enough. Tessellation will subdivide your mesh to a certain degree to give you more geometry, but it does have a limit. So you need to start with a mesh that already has quite a bit. So that's what I've done there. That's definitely worth noting. Other than that though, it's pretty much the same as what we had last time. Now I've already done some of the material work for us because there's no point going over what we've already covered. I've brought in the textures that we'll be using already. They're sitting here in the textures folder, and like before, all of the textures that don't contribute towards color have been set to linear mode. I have unticked the sRGB, including like the displacement texture here. See, sRGB is unchecked, and like before, the normal map has had the green channel flipped. Okay. What I've also done is give us a basic place to start from in terms of our material, but before I go into it, I'm actually going to drag it to the floor plane because it's a good example of why we need to do some work. Now, this floor, while it's quite clearly a nice PBR material, is not looking very realistic at all. If I go down to the ground level, you see it's completely and utterly flat. I mean, if you were looking at it from a distance, aside from the tiling, you might be able to get away with it, but certainly up close it looks like a boring flat texture on a plane, which isn't quite what we want today. Anyway, let's go into our material and let's get to work. So I've already sorted out the basic setup for the material here, like we did last time, or like we did in the first video I should say. So we've got our color, reflection, gloss and normal maps in. The reflection and gloss maps have been inverted like they were last time, and I've also put in some texture coordinate controls. Again, this is all stuff that we've already done. So what I'm going to do now is start showing you how to use the tessellation feature with one of our displacement textures. So let's right mouse button here, type in texture and grab a texture sample parameter 2D node and call this displacement. Should have really named the other ones, but hey ho. And this is going to follow the exact same UV mapping as all of our other textures, so I'll feed that in, and then we just need to change the texture that it's using to the displacement texture, which is there. Okay, so let's start by bringing in a vertex normal WS node. Okay, and then what we're going to do, I mean, this is basically like what's the best way of explaining it, the default state of the tessellation, i.e. none. It's like the position of the vertexes. It's probably the best way to try and visualize it. And what we're going to do is multiply that by our displacement texture. So let's do that like so. And then what we'll do is feed that into the the world displacement, like so. Now I'm going to click on material, and we have to scroll down here and actually turn on displacement. Tessellation. And you've got a couple of modes, flat, tessellation, and PN triangles. The one we want is flat. PN triangles is used on sort of, if you're doing tessellations on quite a dense, complicated mesh, like say a character or whatnot, it helps smooth off the edges. But for a ground surface like this, you want flat tessellation. We're going to turn off adaptive tessellation for now. That's a sort of a performance feature that we're not going to touch. And the max displacement is the max amount that this will displace our mesh. So we'll set that up to something ridiculously high for now because we want to control it via the nodes. Now you'll notice so far not a lot of effect has gone on. I think you can see some slight changes to our material, but it's certainly not quite what we were hoping for. Now you've got a tessellation multiplier here, so what we're going to do is feed that up, feed something into that to see if we can give ourselves some more control over the amount of tessellation. So we'll call this tessellation amount and feed that into the multiplier, and then set that default value to 1, and we'll set these to 0.5 and 3. So let's take a look at 3 and see if that does anything for us. No, it still doesn't. Now the reason for this is all to do with the strength of the displacement at the moment. Okay, so we're going to feed in another parameter and multiply this texture. Okay, so we're getting more strength from it. So let's type in multiply, add that up here, and then feed that into there, and then another parameter because we like our parameters, like so, and we'll call this I'm going to call it tessellation strength. I'm misspelling tessellation, but hey, we'll just ignore that. And let's set this to a value of, I don't know, something like 5 or 6 if I hit the wrong key. And we're starting to get a little bit of a bump coming out of it. Okay, maybe something like, I don't know, 50. Yeah, now we're getting somewhere. A bit too far, in fact. So now I'll take it down to 25. And now you can really see the effects starting to come into place. The basic sphere is being modified quite considerably by the displacement texture, and it's starting to look pretty good. However, because of the way that the tessellation works in Unreal, this would have to be adjusted for every single object depending on the size of the object, because it's the size of the object that dictates the amount of displacement, if that makes any sense. So what we're going to do instead is add in another multiply node like so, and feed that up into world displacement instead, and then we're going to bring in an object scale node. No, that's not right. Object radius, that's the one. There we go. Now what this will do is it will multiply it for us, so we can lower the strength. You'll see now this has gone into like insane mode because it's taking the scale of the object into account. So we can now lower this strength. In fact, the default of 1 might be fine now that we've got that other node in place. In fact, that might even be too much, but we'll see that when I'm going to lower the scale a little bit here. Try and gauge if, oh god, yeah, that actually might work pretty well on a value of 1. So for the min and max on this parameter, I'm going to set it to about 0.2 and about 5. I very much doubt you'd ever need to go that high, but may as well put the control in there. And yeah, that's pretty much all the controls we'll need. Now bear in mind, as you up this tessellation amount, you will be increasing the amount of system resources used and whatnot. And now that we've put in these other controls and we've realized that that wasn't the problem, we can now lower that. So I'm going to set that to 1, and I think that will still give us plenty of geometry. It certainly seems to. Good. Okay, so that's our material pretty much set up. So at this point, let's jump out of here. I'm going to make an instance of it, like so, and then, oh god, that's already got our material on there, hasn't it? So I'm going to click on our divided plane and clear that material, and instead put on our instance. And yeah, still way too strong. So let's go about fixing that. So now that we've got our instance material here, we can go in and set up these settings a little bit. So we've got the gram scale, tessellation amount, and tessellation strength. So what we'll do is lower in fact we'll keep the amount, but lower the strength to say 0.3. Okay? And that is starting. Ignore those kind of that kind of bounds thing. In fact, if I just hit play, it's a bit easier to see then, isn't it? There we go. We can start to see our ground working. And now if you compare this to kind of like the flat imagery that we had before, that is quite an improvement. Definitely some tweaking to be done though. So let's jump back into there, turn down the strength a little more, maybe 0.15, 0.17 maybe. And I'm also going to try lowering the tessellation amount because I think it was using more geometry than it needed to. So let's try that at about 0.5. Let it update. Yeah, maybe a little bit stronger. But this is why you create these parameters and whatnot, so you can quickly tweak and fiddle with it as you're going. But yeah, for the purposes of a tutorial, I would say that we've done a good job. So in summary, we've taken a material from Poliigon.com, brought it into Unreal like we've done before, though this time we used the displacement texture along with Unreal's tessellation feature to physically change the geometry of a ground plane with some interesting results.